working. I think it's working. So, first one. So the first question, we'll have to wait a little bit. Okay. So what is so nice and sweet and kind and makes you happy every time you see a question like that? Denominators are the same. So life is really good. That means you can just add the numerators while denominator stays the same. So that's 16a squared over 4x. Is that okay? Can you reduce that? Yes. 4 and 16. 16 turns into 4. So this is 4a squared over x. And that's your final answer. Yeah? What? Is it 1x or just 1? Oh, well, it should still be x. That x didn't go away. Now, the same thing with the second question. Denominators are the same, but you have to be a little more careful because of the minus. Remember how we talked about when you have a minus, you have to make sure that that negative distributes through the entire numerator. So a good thing to do is just to throw a pair of parentheses around the second numerator to make sure that both signs change. Otherwise, you're not really subtracting. So if we do that, the numerator is a plus b minus a plus 2b. So it's very important that negative 2b becomes positive 2b. So a's cancel. B plus 2b is 3b over 6a. That's what you should arrive at. Yeah? Can you reduce that? 3 and a 6. 6 turns into 2. So you get b over 2a. That is the final answer. Good? Good. Now, the last question is that we have to do a little tweaking. Denominators are not the same as they appear, but we can always, if the denominator differ by both signs, remember how we talked about that? If two positives, two negatives, you can always fix that. So you can pull out a minus out of that second denominator. So we'll make a plus in the middle, right? We can do that. And now tell me what will happen with these two negatives. Positive. So the whole thing becomes y over y plus 5 plus 5 over y plus 5. So now denominators are the same, right? Y plus 5, y plus 5. So you pull it together, and you get y plus 5 over y plus 5, right? Equals 1. If your numerator is the same as the denominator, fraction always comes out to be 1. And again, we're canceling the entire term. It's not like y with y, 5 with 5. We cancel y plus 5 with y plus 5. Is that okay? Make sense? Okay. So let's do more examples. So we're already doing problems when denominators are different. So we have our little algorithm of finding common denominators. So we factor first, and then we take all distinct factors to the highest powers and all that. So here are a few examples where, we'll just have to find the common denominator. So more examples. So what I have here is a plus 5 over a minus 3, a plus 3, plus a plus 4 over a times negative a minus 3. So here it seems that all four different factors, well, different, but there are two factors that we can tweak a little bit to make them look the same. So you see those two factors? Which two expressions can I tweak so they look the same? Well, yeah, but remember, I want everything to be factored. So if it's already factored, that actually makes me happy. If I wrote a squared minus 9, then you would want to factor it into that. But just think about the quiz that you just took. There an expression in the first denominator and an expression in the second denominator that you can make the same by tweaking it a little bit? Which ones? Well, no, not you personally, but the group, but maybe you. Even on the right? And then it's going to look like what? So it'll be negative 8 times a plus 3, right? So then you'll get a match. This will match with that. Well, a is still there. I'm just kind of making a little bit of this kind of preliminary work. But basically what I'm going to get that extra negative. And I can always throw that negative in the middle of two fractions. So all that negative is going to do is going to change the sign between fractions. So I can rewrite this as a plus 5 over a minus 3, a plus 3, minus a plus 4 over a times a plus 3. So what I did, I factor out the negative in that parenthesis and toss that negative in between of those two fractions. This will cut down on the size of my LCD. So then, I don't need to list a plus 3 in there twice. I just need one. So that cuts down on the size of my common denominator, which is good. I want my common denominator to be as small as possible. And now to find the common denominator, we're going to take all distinct factors raised to the highest power that we see. So we see a single a. I need that single a in my LCD. We see a minus 3, so I need a minus 3 in my LCD. And I see a plus 3. I see it twice, but I'm only going to need one of them. I'm only taking the highest power, so I'll just need a plus 3. So that's the LCD. So then I can clearly see that my first fraction is missing an a, and my second fraction is missing a minus 3. Right? That's the big step here to realize what we need to multiply by to get to the common denominator. So I'll repeat that last part. Just any questions on how we got the least common denominator? This is from yesterday. Well, we just look at the highest exponents. I see a plus 3 to the power 1. I see a plus 3 to the power 1. So I just need a plus 3 to the power 1. If one of those was squared and the other one was cubed, I would just take cube. Because cube includes the square in it. So it's already, it gives you the divisibility that you require. So are we happy with the LCD? So what is the first fraction missing in order to get to the LCD? A, right? So we need to multiply the first fraction by a over a. What about the second fraction? Right, so I'm going to need to multiply the second fraction by a minus 3 over a minus 3. Yeah, eventually, yes. But I'm going to take it really slow. I'm going to write it as a times a plus 5, which, yes, will give me a squared plus 5a, minus the product of a plus 4 and a minus 3 all over a times a minus 3 times a plus 3. So I got the two fractions combined into one. The LCD stayed the same. I have a minus in between both numerators. From this step on, it is just simplifying the numerator, opening up all the parentheses, combining like terms, and hoping to factor it and reduce. So the denominator, I'm just going to keep copying it over. I don't even look at it anymore. I'm just focusing on the numerator. I'm going to open up all the parentheses, combine like terms, see what happens. Okay? Any questions how we got to that point? Uh-huh. Yeah, it looks like a 9 or G or Q, I don't know. That's an A. Yeah.
So even though we're multiplying it there, we can't eliminate?
We cannot eliminate because of this big negative in between. Okay? So what that minus tells me is that A minus 3 is not a factor of the entire numerator. In order for me to cancel A minus 3, I would have to have a parenthesis like that, which means A minus 3 multiplies everything. Then I can reduce those two. But as it's written, A minus 3 does not multiply the entire numerator, it just multiplies A plus 4, but not the other half. So this negative separates the two expressions, so we cannot do any reductions yet. The only way to get to reducing is to open up the parentheses, combine like terms, and then try to factor, and then see what we can reduce. So now, this becomes math on I know problem. Just simplifying the numerator. Denominator, we just ignore it, we're just going to copy it over. So, distribute A will give you A squared plus 5A. Minus, I'm going to do the FOIL first, and then distribute the negative. So if I do the FOIL, we'll get A squared minus 3A plus 4A minus 12. All over, just copy the denominator without putting any thought to it. But keep it factored. Keep your denominator factored because you want to try to reduce it later. So all I did is distribute A and FOILed. You can combine like terms first, or let's just drag the negative through. So minus A squared plus 3A minus 4A plus 12 divided by whatever the LCD is. And I'm just copying the LCD over and over. So all the parentheses are opened. I can now cancel a few things, combine like terms, see where that takes me. So, are we happy up to this point? How we got to here? So what can I do now in that numerator? Yeah, what can I cancel? A squareds are gone. Now, if I combine like terms, how many A's do I have? It's 5A plus 3A minus 4A. 4A plus 12 over this. A times A minus 3 times A plus 3. Okay? Well, now you want to try to simplify your fraction. After you're done simplifying the numerator, ask yourself, can you factor that numerator? Is there anything that can be factored? What can I factor? Yeah. If I pull a 4 out, they'll leave me with A plus 3. Right? And now, I can cancel the A plus 3's. Now A plus 3 is a factor of the numerator, and A plus 3 is a factor of the denominator, so I can reduce both by A plus 3. And then my final answer is 4 over A times A minus 3. You don't have to distribute A. If you leave your answer as factored, that's fine. The factored forms they actually give us a lot more information than the expanded forms. So this is the final answer. So that big mess at the beginning turned into this pretty little thing in the end. But again, the steps were first step is to factor, so it was kind of factored, but we just realized we can do a little bit of tweakage, pull a negative out, so the negative change the sign in the middle. Then we found the LCD by pulling all different factors. Then we multiplied by what's missing, right? So it gave us the LCD, and from this step on, from this step right here, we just went on to simplifying the numerator. Denominator was not an issue anymore, right? We didn't look at the denominator up until this final step where we factored and reduced. Good? They're pretty lengthy problems, so they require a lot of skills. We FOILed, we combined like terms, we factored a few times, so everything you've learned in this one problem, right? Feels good? Let's do another one. N over m squared plus 2mn plus m minus 2n over 4mn. So we have to find the least common denominator, but before we do, we have to factor first. So is there anything I can factor in that first numerator? First denominator? Yeah, I can pull out an m. So we have n over m times m plus 2n plus m minus 2n over 4mn. So everything is factored, so we can start pulling things together to find the common denominator. So again, remember, we just need all different factors that we see to the highest power. So I see that number 4, that lonely 4. I need 4 in my LCD. I see m twice, right? The first denominator has an m, and the second denominator has an m. But I just need one m in my LCD because I just take the highest powers. Then I see an n, I need n, and I see m plus 2n, I need m plus 2n. So again, you just grouped everything together without relisting same factors more than once. So that's that, right? 4, one of the m's, m, and m plus 2n. So I need all of these terms in my LCD. Okay? So this will tell me exactly what's missing in each fraction. I'm just going to compare each denominator to the LCD, and that will determine what I'm missing. So if you look at the first fraction, n over m times m plus 2n, what is it missing? For n, right? You're comparing this denominator with the LCD. M is there, the parentheses is there, but you're missing 4 and n. So we're going to multiply by 4n over 4n. What about the second one? What is the second one missing? Right, it's missing that entire term, m plus 2n, m plus 2n. So that equals to 4n squared. Is that okay? Multiplying n and 4n plus the product of m squared. I'm sorry, let me not do that yet. The product of m minus 2n, m plus 2n, all over the LCD. Is that okay? How we got to that point? So n and 4n gave me 4n squared, and then I have a product of those two parentheses. Is there a really quick way to multiply those two parentheses without actually doing the FOIL? Right, it's m squared minus 4n squared. It's just our difference of squares formula. So 4n squared cancels with 4n squared. Which leaves us with m squared over 4mn and m plus 2n. So are there any common factors in the numerator and the denominator? What? Yeah. Because again, remember, this is 4 times m times n and so forth. So the denominator is a multiple of m, and the numerator is a multiple of m. So I can cancel one of the m's in the numerator with m in the denominator. Okay, so the numerator had m times m, now it just has 1m. So we're down to m over 4n times m plus 2n. And there's the final answer. Nothing else we can do. Is that okay? Any questions on this one? Well, yeah, I don't know. What is this? Oh, I wrote it wrong, right? Yeah. Yeah, I wrote it wrong. Well, why didn't you tell me, right? Yeah, I wrote it wrong. This is that for MN. Sorry. You were quiet for so long. This is awful. It was just I just wrote it wrong, and the rest is correct. I just, Yeah. Any other questions? This is good. Yeah. I just wrote the fraction wrong. Yeah. Thank you. Any other issues? The rest is correct. It's just I just kept going the way it's supposed to be, because it really didn't make any difference because I knew the LCD, what the LCD was, and it just kept going. My numerator was correct, which is more important. Yeah, I just wrote that fraction wrong. Okay, good. So those little tweaking tricks, little tricks that we've been doing. So there are a few of them. So we realize when we had expressions like, two negatives, a, negative a, minus b, we were always able to pull a negative sign out to make it negative times a plus. So we were able to do that on the quiz and on the earlier problem. So that's one trick that we'll be using a lot. Another trick was if you have to flip around the negative, if one is a minus b and the other one is b minus a, if you flip around the negative, if you want to turn a minus b into b minus a, it also changes the sign. So a minus b is the same as negative b minus a. And we've used these two before. But there is another one, because sometimes you have a minus b squared, but you wanted to make it b minus a squared. So you want to flip inside the square. And we'll see this in the next example. So here's the connection between these two lines. A minus b and b minus a, they differ by a sign. So it's like 4, negative 4, 7 and negative 7. But here I'm squaring them on the next line. If I square two terms that only differ by a sign, like 4 and a negative 4, what will happen? Yeah, they'll both be positive, so they'll both be equal. So if you flip inside the square, nothing really changes. And another way to see that, we know that this is a squared minus 2ab plus b squared, right? This is our formula. While the other one is b squared minus 2ab plus a squared. So they're actually the same, right? They just, one has a squared up front, the other one has b squared up front, but they're the same expression. So just keep that in mind. It is always okay to flip around the negative inside the square. Nothing really changes. The square takes care of the negative. It's always okay to flip around the plus. That should be clear that a plus b equals b plus a without any extra work. But to flip under the square, you can always flip under the square. Because the square takes care of the negative. Both expressions will be the same. Okay? So there are the three major tricks that we'll be using when trying to tweak our denominators a little bit. So if you have two negatives, it's always okay to pull it out. If you want to flip around the negative sign, make sure you change the sign of your expression. But if you flip around the negative under the square, nothing changes. You can just flip under the square. No problem there. So, which takes us to this next example. We might use some of these tricks there. 7n squared plus mn minus 8m squared all over m squared minus 2mn plus n squared minus 8m over n minus m. So the first step would be to factor your denominator. Okay? So if you look at the first denominator, is there a really quick way to factor that one? How would you factor the first denominator? You have m squared up front, n squared in the back, negative 2mn in the middle. What is that denominator? Yeah, this is your formula, m minus n squared. That's one squared double product, the other one squared. Is that okay? So here, if you look very closely, one says m minus n, while the other one says n minus m. Those are different. So you have to make them look the same. So you have two options. You can flip the second denominator, but if you flip the second denominator, the sign will change because you flip around the negative sign. Or you can just flip inside the square. Nothing happens when you flip inside the square. You don't have to keep track of that extra negative, and that's what I talked about here. If you flip under the square, you can just always do that. So it seems to be easier to just rotate around the square. Don't have to worry about the extra negative. So let's just do that. You can always flip inside the square. You can flip the other one too, change the sign. It will still work. But under the square, nothing happens. So I can actually rewrite this as 7n squared plus mn minus 8m squared over n minus m squared. So I just rotated around the minus. Under the square, I can always do that. Nothing really changes. Those are the same terms. Minus 8m over n minus m. So this allows me to find the LCD. Well, that's what I was talking about here before, that they're the same. Yeah, so this is the same thing. If you flip around the, because if you flip under the minus, if you flip around the minus, the sign changes. But the square kills that sign, so you're back where you started. So what is the LCD? N minus m squared. N minus m squared, right? So you have n minus m squared, and then you have n minus m. Pick the highest power. So you only need n minus m squared. Pick the highest power. So that means the first fraction is happy. It already has the least common denominator, while the second fraction needs what? Well, I cannot just, yeah, n minus m. I cannot square it because it will change the problem, but I can only multiply n minus m. So that's what I'm going to do. The second fraction, I'll just have to multiply it by n minus m over n minus m. So now denominators are the same. So this is what we have. 7n squared plus mn minus 8m squared. I'm just copying the first numerator. And then minus 8m times n minus m, all divided by n minus m squared. So all I did, I just pulled the two fractions together. Haven't done anything else. So at this point, I'm going to open up all the parentheses, combine like terms, see what that's going to take me. Okay? So there's only really one parenthesis to open. So I'm going to distribute negative 8m, which gives me negative 8mn plus 8m squared all over n minus m squared. Is that okay? So at this point, you want to combine like term, simplify that numerator. So what can I do? Yeah, 8m squared, they're gone. And when you combine like terms, you get 7n squared. And then we have what? We have mn minus 8mn. Minus 7mn. So we combined the numerator, we collected all like terms. At this point, we want to try to factor and reduce. So is there anything I can factor in that numerator? 7n. So if I take out 7n, it will leave me with n minus m. Right? If 7n goes out, leaves me with n minus m over n minus m squared. So that tells me that I can cancel one of those n minus m terms. That entire factor goes away. So n minus m cancels with one of those, which leaves me with 7n over n minus m. And that's it. So did I do anything silly again, or was it better? So again, this is the trick that we used. If you feel like you can always fix that negative thing. Otherwise, your LCD would be really big. If you don't flip that, you need m minus n squared and n minus m in your LCD because they look different. But if you do that little tweaking first, your LCD becomes much smaller. So we had two options. Flip under the square and then nothing really changes, no extra sign. or flip the second one and then change the sign. The answer would come out to be the same. Okay? So either way, you might have to do another flip in the end. But so we can do those little flips. Any questions on this one? Good? Makes sense? All right. Which takes us to our worksheet 8, which is kind of a famous worksheet. It was never finished in the... Well, I've been doing these worksheets for a while now, and I have one student in all the years and semesters who finished worksheet 8 in class. So it's a challenge. So it's going to be most likely going to end up taking it home and giving it back to me on, let's do it on Tuesday, next Tuesday. Okay, because you have a homework on Thursday. It's, you know, it's a staple, technically, 2-page front and back situation. It's big, but it's good for you. So yeah, if you get it done today, good. If you don't, turn it in on